This is part 5 of section 5.1 and 5.2. Okay, so we're doing scientific notation. We have just gone from standard notation into scientific, and now we're going to go from scientific into standard. Now, I showed you how you can enter this on your calculator, and yes, you could get your answer immediately. One of the things you have to be careful about, though, is when you're making a big change, sometimes a calculator will cut off a digit, and that messes up everything. So you have to be smarter than your calculator in this case. Okay, so when you're going from scientific into standard, your first step is usually kind of ugly. What I want to do is I want to take 5.42, and I know I want to move my decimal point 4 spots. It's just a question of which direction. This is a negative exponent, so this number should be getting smaller. If I start moving my decimal over here, it's getting bigger. So I'm going to take this decimal, and I'm going to move it 4 spots. Well, that's 1, 2, 3, 4. So my decimal point's here. And I need to fill in zeros for everything, every little bump I made that didn't have a number in front. So I strongly suggest that you put the 0 in front of your decimals. Because it's very easy when you're working. If you the decimal point can look like a stray dot, you can lose it. I've done it several times. So let's take 5.42 and then raise it to the -4 to power and check our answer. And we're good. Okay, so let's try this one. Okay, so I want to, it's going to be negative, I know that. Okay. I have -7.83159. And I know I want to move my decimal point 7 places. And since this is a positive exponent, this number needs to be getting bigger, ignoring the negative. Okay? So I'm going to move this 10 spots this direction because that's what makes it bigger. 1, 2, 3, 4, 5, 6, 7. So I should be adding 2 zeros here. And your answer is -7.8315900. Add your commas. Let's see what we got. And it looks like I got it right. Okay, so our last problem is something that looks, not just switching back and forth. We want to solve this problem. I'm going to work it with standard notation, so just as it is, and then I'm going to work it using scientific notation. You can see, this will enable you to see the advantages and the disadvantages of using these numbers. Okay, so if I'm doing it with standard, I have order of operations, which means I need to do parentheses first, which stands for any grouping symbol. And the fraction bar is a grouping symbol, so I need to do that multiplication across the top first. 40,000 times 0.003 is 120. And then I want to divide it by this. How many zeros do I have? 3 zeros. When we have large numbers, we use commas to break it up in groups of 3. And decimals, we don't do that. Occasionally, you'll see something written like this, where they give a space between every 3 digits, but you don't see that very often. And this is where the mistakes can come in, big mistakes, okay? But now all I have left is the division, 120 divided by 0.00012, and that would be, again, a number that's large, 1 million. Okay, so now let's try it using scientific notation. What I'm going to do is I'm going to change each of these into scientific notation. Okay, so for here, I'm going to do it above. I'm making my decimal point move all the way over to here so that I can have one number in front that is not a decimal, which is not a 0. Sorry, I misspoke. So this will be 3 times 10 to some power. I've moved it 1, 2, 3 spots. The 3 needs to be getting smaller to go back to this, so it's going to be a negative exponent. So this first number is 3 times 10 to the -3. Times, So this is my first number. I'm going to draw in some parentheses so it makes it easier to see, but the parentheses are not necessary. Okay, now to change 40,000, my decimal point is here. I need to move it all the way over to here. So I have 4 times 10 to some power. I've moved it 1, 2, 3, 4 spots. And 4 needs to be getting a lot bigger to go back to 40,000, so it's a positive 4. Okay, now for the bottom. I'm going to take this decimal point and I'm going to move it all the way over so it's between the 1 and the 2. So I have 1.2 times 10 to the 1, 2, 3, 4. And this needs to be getting a lot smaller to go back to here, so it's a negative. Okay, so I've done all that. Now what I'm going to do is this is all multiplication. Every single bit of this is multiplication. So I can rearrange things and multiply things however I want to. So what I'm going to do is I'm going to do 3 times 4 to get 12 times. Now I'm multiplying 10 to the negative 3 times 10 to the 4th. By property number 1, I add those exponents. Negative 3 times 4 is 10 to the first power. And I'm just going to do okay. So now what I can do is I can combine these. This is a simple division. I can do 12 divided by 1.2. And you get 10. So when I divide these, I'll make a little circle here. When I divide here, I get 10. And then right here, what I'm going to do is I have the same base. And I'm dividing, so I subtract those exponents. So what I've got right now is 12 divided by 1.2 is 10. And then by using property number 4, I have, this is times 10 to the 1 minus a negative 4. Okay, which is, all right, 10 to the first power times 10 to the, that's 1 plus 4, which is 5. Which, when I multiply these together, I get 10 to the 6th power. Okay? Now, this is not in scientific notation, but all we have to do is, if this is our answer, to write it in scientific notation, we only have to multiply it by a 1. And it's truly in scientific notation. I start with a 1, and I'm going to move my decimal point 6 spaces so that it gets bigger. So I start with my 1, and I'm going to move this thing 6 spaces. 1, oh wait, no, it's right here. It starts off right here. So that's, let me change color pen. Okay, moving the decimal place that we start in the right spot is 1, 2, 3, 4, 5, 6. Fill these in with zeros. And then make it look a little bit nicer, and you'll see that your answer is still 1 million. This would be your answer in scientific notation. This is your answer in standard notation. I think you can see how this can get bad, especially in the sciences. If you drop a 0 and you're trying to get to the moon, you miss it, okay? And so this makes it easier to not drop things. But again, it can be a little bit ugly. You have advantages and you have disadvantages in both methods.